Okay, back for a new topic, and this topic that we're going to do is exception handling and I/O. So remember on the notepad program I talked about that we're going to hit both of these two topics on the notepad program, file I/O and exception handling. So this is the lecture that I was supposed to cover before the notepad stuff, the notepad program. So kind of did it in reverse order only to mix things up a little bit, make it a little bit easier to follow along, not so much PowerPoint in a row, kind of mix it up a little bit. But this is the overview that we're looking at. Java is a wonderful language for exception handling. It's completely built in, which is nice. We just throw an exception, look for something, catch it. So what I'm going to do is kind of briefly go through the concept. If you want examples of it, go back to Notepad. We have both file I/O and exception handling in there. Usually the two concepts work together because we're going to do some exception handling when we open up files. So why do we want to do that? Because if the file doesn't exist or something, or if we have a problem with it, we want to catch it. Otherwise our program functionality isn't going to be too stable after that. So what you're looking at is an overview of the exception hierarchy. Simplified diagram here for exception handling in Java. We have this class level called throwable. And then we have a couple of different types of throwable components. We have errors and then we have exceptions. On the error side, well, that's kind of self-explanatory. Something went wrong. There was an error. On the exception side of things, then we have things that come up in terms of I/O exceptions, runtime exceptions, and different categories where we can stick things in. All of the exceptions extend the class throwable. So we're looking at an inheritance here, which immediately splits into two hierarchies, error and exception. Errors are internal errors, resource allocations, exhaustions, inside of Java, runtime problems. Yes, a garbage collection that fails. You can't really do anything about the errors. What you can do on the exceptions is catch them and deal with them. So you can reroute the execution of the program to deal with the exceptions that are going to come up. So focus is on the exception branch of things. We have two branches of exceptions. Runtime exceptions in terms of derivations of exceptions that are derived from runtime. So what we have are examples of bad casting, out of array access, which could cause a runtime. Happens because errors exist in your program, they're your fault. Or we have those that are not in the runtime exception class. Examples of trying to open a malformed URL. Not necessarily your fault, maybe the URL is not there anymore, maybe it's not formed correctly. The program is good, but bad things happen, not necessarily your fault. So what you want to do is essentially be able to prevent the program from bombing out unexpectedly, those unexpected errors that occur. So exceptions, checked exceptions versus unchecked exceptions. One thing to remember is that exceptions are going to happen with or without your involvement. They're just going to happen. If the file, you go to open up a file in your notepad program and the file is not a text file and it can't read it correctly, then it's just going to happen. So if you catch it, then you can deal with it, like maybe put up a warning message and say, hey, this is not a text file. This is a binary file or something like that. Or you can just go ahead and open up the binary file and see what happens. So unchecked exceptions are exceptions that are derived from the class error that are on the runtime exception. Those you can't catch. So sometimes the biggest popular thing is when you see runtime exception. In fact, I saw some when I ran one of my notepad programs. I'm not quite sure exactly what I did to it, but I was actually able to see it in the console window underneath the code. So checked exceptions are all the exceptions that are not unchecked. So they fall into a different category. So if they occur, you must deal with them in some way. What does that mean? Catch it. So the compiler will check whether or not you provided an exception handler for the checked exceptions. If you have, then it will run your exception. So declaring and throwing exceptions, very similar to C++ actually, very similar to other languages. We can put a throw clause at the end of our method. So a Java method or constructor should be declared to throw exceptions under two different situations. It calls another method that throws a checked exception, or it throws a checked exception with the throw clause statement inside the body of the method. So we'll see some examples in a few minutes here. So you declare a method or constructor to throw an exception or exceptions, you can throw more than one, by using throws in the method header. So here's an example of a single exception. Public file input stream, and this is all in one line by the way, a string s throws file not found exception. This is in the method header, and then we have our opening and closing brackets, and we have the method body that shows up underneath it. Or we have multiple, we just separate them out by commas. So we can have multiple exception throwing and handling. So here we have public image load throws the end of file exception and also the IO exception. Lucky for us, all of these are built in. We don't have to define any of these exceptions. We just use what we have, kind of like all of the other things that we've been seeing so far in terms of objects. So she should not declare an unchecked exception after throws. They either are outside of your control or they should be avoided completely by correcting your code. So how do we use the throw? We've seen it a couple of times. So I don't have to necessarily go back to that code, but if you've kept the notepad stuff on your computer, it's all over the place. Because with Notepad, we're opening and closing files constantly, so we're always going to check to make sure the file exists. And then we're reading the file in, so we're going to check to make sure we got to the end of the file. And very popular use of exception handling is with file I/O. So using the throws to throw an exception. Under bad situations, an exception might be thrown. Actually, under good tones too. Some of them aren't predictable. So we have, in this particular example, a method named read data. This actually comes out of the Notepad example. It's reading a file whose header says it contains 700 characters. We got the length of it, and we want to make sure that we're going to get all these characters when we read it in. But it encounters the end of file after only 200 characters instead of 700. There's something wrong with the file, which happens actually. Bad file. So you decide to throw an exception when this bad situation happens by using the throw statement. So we do throw new end of file, or we can go, and we've seen both actually in those Notepad examples. End of file exception E is equal to new end of file exception, and then throw E. If we're going to throw E, we're going to do something with E as it comes back. So we throw it. This is the more popular method of doing it. There's a popular way of doing it. Actually, all you have to do is look for any type of throw clause, and then you'll see how you're going to work with the E. So the entire method looks like this. String read data. We're going to use the scanner class, and I'm going to talk about scanner in a few minutes. Scanner in throws end of file exception. While something happens, if not in has next end of file encountered, then if n is less than the length, then throw the end of file exception. So we throw the exception and then we deal with it when the exception actually occurs by printing something out to the screen or closing a file or reopening something, doing something with it. So using the throws in the exception to throw an exception. In the method body, you can only throw exceptions which are the same type as the subclass of the exception that's declared in the throws. So you go from that level down to subclasses inside of the method. And you can find an appropriate exception class in the library, make an object of that class and throw it. Otherwise, you can design your code with your own exception class. All you have to do is inherit from exception, and you can create your own exception. So creating new exception types. Exceptions are objects. New exception types should extend exception or one of its subclasses. Lucky for you, you don't have to create any exceptions. But if you go on to further advanced programming, this is sort of the intermediate level at this point. In an advanced situation, you would want to throw something to catch. You'd want to throw your own custom exception to look for something that was going to be a subset of something else that perhaps you want to modify it. So why creating a new exception type? Describe the exception condition in more detail than just a string that the exception provides. What's that going to do? Well, it's going to assist, let's say, a receptionist or somebody who's using your Java program, and instead of it saying end of file or expected another token or some of these other exception messages that come out of the exception handling, it could say something a little bit more user-friendly to the admin who's using your program who has no idea about Java. something that might come back and say, missing social security number, or incomplete information, please try again, or something where it would actually aid a little bit more in the entry to fix the problem. So here's an example. Suppose there's a method to update a current value of a named attribute of an object, but the object may not contain such an attribute currently. It doesn't have the attribute. And we want an exception to be thrown to indicate the occurring of this particular situation when it happens. We can have a new exception here, public class, no such attribute exception, that extends exception. So this is the first time we're sort of seeing extending built-in classes outside of collections. Another common way, common thing that a lot of programmers do is they extend the exceptions. It's like this. Public string attribute name, which is going to be a piece of data that's being used by your class. And then your constructor here that says no such attribute with the string, taking the string, and then it's going to print out super no attribute named. So it's going to call the super from exception that prints out the message, but it's going to call it with the text that it wants to print out, which is a constructor of super. That says instead of printing out the default text, print out this text. And this text is going to say no attribute name such and such found. And then have the attribute name equal to the name. So fix it or something, do something with it after that. So the type of the exception is an important part of the exception and the data that the programmer is going to use. It needs to be some action exclusively in one type of the exception occurs, not others. So you're catching each one of the exceptions. So you're dealing with each one individually, but you're catching as many as you can that might be appropriate for the situation that you're trying to deal with. So that's how you throw an exception. Well, if you throw it, you got to catch it. So if you're familiar with try, catch, it's the same concept. You throw it, try something out. If you have a problem with it, catch it. The catch block essentially is going to deal with the behavior that occurs. So catching exceptions. So checked exception handling is strictly enforced. If you invoke a method that lists a checked exception in the throw clause, you have three choices. Catch it, deal with it, handle it. Declare the exception in your own throws clause, and then let the exception pass through your method. You may have a finally clause to clean up things first. Or catch the exception and map it to one of the exceptions by throwing an exception of the type declared in your throws clause. Catch it and throw it back to the main object. So here's the try-catch example. So this is an example, first example here. Basic syntax, you might be familiar with this in C++ or other programming languages, actually C as well. Actually Objective-C, you can do a try-catch in that as well. So try, open up a file. So the statements are going to do something that's going to raise an exception. Catch, what are we going to catch? Exception number 1, exception number 2, exception number 3, exception number 4. Because what happens if we try to open up the file and the file's not found? We're going to get a file not found exception. Or what if we open up a file and it's corrupted, you can't read the file? Or you can't open the file, but the file's found but you can't open the file. Can't open exception. Or any one of the other situations that might occur. Because then you can tell the user, hey, file not found. Or tell the user, file found but can't open the file. Or wrong file name or bad file name. Or, I don't know, something odd. So if no exception occurs, none of the try blocks are actually going to, none of the catch blocks are actually going to occur. Try is going to always run, regardless of what we do. Catch may or may not run, depending upon what condition we actually run into. So if no exception is found, the statement's in the try clause. It finishes execution and all of the catch clauses are skipped. If any of the code inside the try clause throws an exception, the one that's thrown is the one that's going to be caught, hopefully. And so either directly or indirectly via the throw, then we've invoked one of the catch clauses. So the throw is indirectly by a method invoked inside of it. The program skips all the remaining code in the try. The catch clause are examined one by one to see if any of the types of the thrown exceptions match the ones that are specified in the catch. If none of them match, none of them are actually going to get caught. But if one of them is matched in the catch, So if the appropriate catch clause is found, then the code inside of the body executed, all the remaining catch clauses are skipped, but the code inside of the body of the appropriate catch is actually executed. But all the other ones are skipped. So only one of them for each one of the exceptions is going to be run. No such catch clause is found, then the exception is thrown into an outer try, if there's an outer try. That might catch the clause and handle it. If there's not, it just goes away. What does that do? Unpredictable behavior. So you want to basically try and catch all of the conditions that might actually exist. Catch clause with a super class exception type cannot precede a catch clause with a subclass exception type. So the subclasses go first. So here's another example. You put it together. What do we have here? Read. It happens a lot with file names and reading files. So void read, give it a file name to read. Try, we're going to create an input stream. I'm going to talk about that in a few minutes. Input in is equal to new input, new file input stream for the file name. Then we have integer b that's declared. And then the read here is going to, the read method. The method itself below is one of the ones which is going to throw an IO exception here. So while b equals in.read doesn't equal -1, so we're going to go back to 0. Process the input, and then catch IO exception e, and then exception.print stack, which is going to print out the Java created exception that's going to exist, which is all that, line number. Actually, all you have to do is open up your Eclipse window and look at the bottom console, and you'll see a bunch of exceptions down there. Naturally, it just happens constantly. Whether they're caught, probably not in your program, but they're going to be memory related. Sometimes you'll see memory related exceptions. When we ran the first Android example, you're going to see tons of exceptions that are constantly caught. And people often get concerned about that. They're wondering, why are all these exceptions being caught? I mean, why aren't they all being dealt with? Why do we get so many exceptions and errors and problems? It's not us, it's the emulator that's throwing them. So they don't necessarily get thrown on the real device, it's the emulators that are throwing them. Well, I'll take a look at that. We'll take a look at that as we go through some examples live. So the good thing about exception handling is it's tedious to put it together. Once you've put it together, it's very helpful in troubleshooting. Because then you can see, it's not like an NSLog or something, or no, that's the wrong language. No, that's the wrong language. No, NSLog? No, that's the wrong language. That's iPhone. Toast. That's Java. It's kind of like toast messages or log messages. I had to think back from Java. I was doing Objective-C stuff last night, so now my mind is back in the wrong track. I was on Java for the longest time. Now I went back. All right, so log, toast, something that would basically put an error message or something to the screen, say, hey, made it here. Hey, did not make it here. Something like that. Exception handling does that for us in the runtime of the program. So while the program is running, we can sort of deal with what's going to happen, especially when a file is not found. Okay, so here's the other example. How to throw an exception in a catch clause. Typically you do this because you want to change the exception type to indicate a failure of your subsystem, so you can tell the main system that there's a problem in the subsystem. So you're going to throw your own exception. So you're going to say try access the database. Catch an SQL exception E. And then in the catch you're going to throw an SE. This is the temporary name you're going to give the method that you're going to, the instance of the object that you're going to throw, and it's going to be a new servlet exception database error. So that exception that you're throwing in the catch is going to come back to the main method or main class or object that called this method, a sub part of your program. It's going to say, hey, we had a problem connecting to the database. So then it can deal with what happened with the database and say, going to come back and say, hey, database is offline right now. Can you try again later or something? Or, hopefully some user-friendly message will come out of that. So when the exception is caught, the original exception can be retrieved. This is called chaining. All of the exceptions are kept. If you've caught them, you've kept them. So use a chaining technique that allows you to throw higher level exceptions in subsystems without losing the detail of the original failure. So throw E equals SE get cause. Get cause from the lower level. Then we have the finally clause. So you want to do some action whether or not an exception is thrown. So it's kind of like default, or used for different purposes, but it's the finally clause. So we have try, catch, finally. And so what do we have in here? We're going to dispose of something. So graphics G is going to be equal to image.getGraphics try. And if you're familiar, look at Hello World for swing. We used a graphics G, which basically just gets at the graphics system. Let's see, but that's not swing, that's a graphics package. Graphics objects. So then try, do something, catch something, catch something, catch something. On the bottom we have finally some code which is not, after you've not thrown an exception, finally is going to go and clean things up. So we could dispose of it, garbage collect it. Do we really have to garbage collect? What ends up happening is, especially when we're opening up a file, we want to close a file. So finally could actually, after we've done something to it, close the file, clean up the mess. So reserve, yeah, put the resources back. Why do we want to do that? Because then we might throw an out-of-memory exception further down the road if we don't put things back after we've used, after we've created memory and stuff. So no exception is thrown. Exception is thrown and caught. These are all the different scenarios that could exist. In fact, these are the numbering 1, 2, 3, 4, 5. So 1, 2, 5, 6 is going to happen. The slide has us moved up too far. This should be next to here, actually. But if no exception is thrown, we're going to have 1, 2, 5, 6. So 1, 2 from the try, and then 5, 6. So the finally is going to go, and then the default's going to end essentially. And then an exception is thrown and caught. Well, 1, 3, 4, 5, 6, depending upon which one is caught. So you can kind of follow this through. The catch clause doesn't throw in other extension. The catch clause is going to throw an exception itself. We have the different scenarios. What's going to happen? We've seen all of this live, so I'm not going to kind of go through this fast because it's kind of boring for the most part. So, finally clause. The final notes on the finally clause. You can use the finally clause without a catch clause. You don't need a catch clause for that. You can go try finally. Sometimes the finally clause can also throw an exception. If you try to dispose and we have a problem because it's still open, we haven't closed something, or we're trying to dispose something that's already open, we might throw an exception. So we can put some exception handling in the finally as well. And as an example, here's one here where we have a throwing a search for, and what are we searching for? A string with a word inside of a string, and it's going to throw the stream exception. So we have stream input is going to be equal to null. Try some code that might throw a stream exception. In the finally, we're going to put input.close. So this might actually throw an IO exception if we can't close it. So if it does, then we can catch it. So we can actually nest this, by the way. We can put it inside. We can put a try catch finally inside of a try catch finally inside of a try catch finally. We can also nest it inside of the methods. So one method's calling another method, calling another method. That's also using try catch. So tons of ways of nesting it together. If your try clause throws a stream exception and the finally clause throws an IO exception, the original exception is lost and the IO exception is thrown instead. So if this throws an exception, you want to make sure your finally is pretty safe, because if you throw an exception in here without catching it in here, this out here is going to be lost, because it's going to replace the current exception with the finally exception, because it's going to essentially take whatever you had out of the queue. So that's my short spiel on exception handling, just so I can say that I've given it to you. Are you going to use it? Hopefully. Do you have to use it? Not really. Do you have any programming assignments with it? No. Is it testable material? Yeah. Is it part of most programming? Yeah. Is it what programmers like to do? No. So, it's kind of like documentation in a lot of ways. But the more you use it, the more practice you do with it, the easier it becomes. In fact, Eclipse is trained to make you do it. So if you try to do something with file I/O, it'll tell you and prompt you, and I'll make it. Sometimes it makes it into an error too, and it says you have to do this. Do I have to do it? And then it'll put the code in for you. So it actually write the try catch for you. and put it all together, and it will even put in the throw of the common exceptions for you. It won't write your exceptions for you. You'll have to create your own exceptions if you want to do custom exceptions, but it will try and force you to use it, which is a good thing about using Eclipse. If you don't use Eclipse, then you're never going to see any message. No one's going to force you to do it. It doesn't force you to do documentation though, which is great. It doesn't force you to do Java docs, which is great. So, next topic. We're switching topics now to the other topic I said I was going to tell you a little bit more information out from a concept perspective is I/O. We saw it with the notepad program, so we've seen some of the syntax, but let me talk about what the syntax is actually doing. We have an I/O package, java.io. So we include java.io. You'll see that in the package imports for a lot of those examples for the notepad. What are we looking at? Streams. We have different types of I/O. In terms of streams, we have the ordered sequence of data from the source, so the input stream, or the destination, output stream. So in the notepad, we were working with strings that we were reading or creating from streams that we were taking from files. So the two major parts are the bit streams and the character streams. We were using character streams, actually. In the bit stream types, we have 8-bit based systems. Input streams and output streams are there. For characters, we have readers and writers. So most of it was our reader in, reader out, or buffered reader, which I'm going to get to in a few minutes. But we have buffered and we have non-buffered I/O. Same thing we get in other languages like C++. Check out the API documentation for details about Java I/O. Well, if you want the nitty-gritty details, yes. In terms of using it, the notepad examples I gave you have all of the FIO I/O stuff in it. There's examples of every one of these in here, except for perhaps maybe the byte streams. I'm not sure if any of them are going to work with bytes, but they're going to work with characters, which is almost the same. Two parent classes. They're abstract classes, input stream and output stream, as you might guess. Reading bytes. The input stream, actually there is an input. We are using bytes actually in one of the notepad ones. Depends on how you want to read it from what level of abstraction. The input stream class defines the abstract method public integer read, which throws an I/O exception. So the designers of a concrete input stream class have overridden this method to provide useful functionality called file input stream class. It reads the file instead of just an input. So we can read, well, the scanner class actually will scan I/O from input output, so without using files, which is actually interesting as well. So file input stream class, the method reads 1 byte from a file. The input stream class also contains non-abstract methods to read an array of bytes or skip a number of bytes. So reading bytes. Writing bytes, we have the exact opposite. The output stream also throws an I/O exception. So naturally it's appropriately defined here. We have void write. So we have integer read, void write. Integer is going to actually return the number of bytes that were read. So we can check to see what is the length of the file, read in the file, how many bytes were read. So the read file returns the size of the bytes that were returned. And it's an integer value, so we can compare that to see if we've actually read the entire file. And then we're going to close the stream after reading and writing and free up the memory of the operating system by using a close clause. So here's an example. This actually works. If you cut it and paste it and stick it inside of a Java class and run it, I don't believe I have a main method in here. It's just going to be the count bytes. Actually, there is a main method in here. So if we cut and paste this, stick it inside of a Java file, we can read and write. We also did this, however, with the notepad file. So, matter of making our life simple, I'm not going to cut and paste it and stick it in, but you might want to try that. You could do it. This example will work, and this is lecture number 7, by the way, if you're looking for the source code example. So what are we looking at? The void main that's going to throw, so on main we're going to throw the I/O exception. So it throws I/O exception because main is actually opening up the file. So we're importing java.io, and we're going to make an instance of this class, and we're going to call it in. So file input stream in is going to be equal to new file input stream, and the arguments So when this particular program runs, it's going to take command line. Is that my phone or somebody? Something's blinking. Okay. Okay. I just want to make sure it was my system telling me something. So, all right. So we have arguments that are going to come in from the command line arguments, which is where this is coming from. So you load this file. It says count bytes space, and you give it a name of a file. And the name of the file is going to be read in from the command line, and we're going to use a file input stream that's going to count the bytes. So in total is equal to 0, integer total. This is the temporary variable. It's going to keep the total. So while in.read doesn't equal -1, which means it's going to come back with nothing. Total plus plus. So we're going to keep a fake counter in here that's going to count the number of bytes and increment it every time we're reading a byte in, 1 byte at a time. In.close, system out the bytes. So it's reading it 1 byte at a time, which we're going to get automatically with a file input stream. As opposed to code example number 2, well, code example number 2 is also working with bytes, and we're going to translate the bytes. So translate bytes. Byte from byte, we're casting the argument of the first file argument that we're going to load in. It says count the bytes, argument dot character at 0, first character. Byte to byte, well, we're going to take and cast to byte. So this is object casting to byte. We've seen before with person and employee. We took an employee, casted them to a person. It's doing the same thing, actually. Integer x, while x is going to be equal to system in.read, we're going to get it from the system input. We're going to take the system input, character by character, and we're going to read the bytes in so we can know how many we've got. And here x is going to be compared to from 2x, while the bytes are actually being put into the system, we're just going to read it in. Not really doing anything with it. It's just going to basically run it. So you run it Java translate AB, which is going to translate it from lower to upper, and then enter the text for big boy via the command line prompt, and it'll actually go through the translation for you. So not to worry about it. It's just an example here of looking at the concept of the bytes and the input stream, which is actually doing the read in. This is actually reading it in. So we have worked with a lot of system.out. System.in is doing the opposites, the inputs, so from the command line console. Character streams. This is what the notepad is actually working with. So all of the notepads are working with character streams. So two parent abstract classes come from here, the readers and the writers. So we have a reader, we have a writer. Each has supported similar methods to those of the byte stream that we looked at, input stream and output stream respectively. So we have the standard streams, standard in, standard out, and standard error, which is input output error, which comes from the old Linux actually. So input output is a three I/O subsystems. So it exists before the invention of character strings, long before the invention of character strings. This comes back from Unix. So they are byte streams. Through logically, they should be character streams. So we're going to look at them from a character stream perspective and conversion between bytes and character streams. So we have input stream reader and we have output stream reader. So it translates between Unicode and byte streams. So here are the input stream reader that's going to take in a string encoder along with a stream. So we have different ways of calling the constructors for these particular objects as we create the input stream and the output streams. Output stream writer using the string here for character encoding. So read reads the bytes from the associated input stream, converts the characters using an appropriate input stream that was given to us. One of them I think we actually specified a UT8 or something. One of the notepads actually, most of them just specify the input stream that's coming into the input stream reader. And this is going to be the file, or it's going to be a string or something that's going to be associated with it from the contents of the file as it's read in. Or it's going to be also read in and then also translated to some sort of a character bit, a character notation, character format. And I think one of them actually uses a UT8 or something like that in there. So I'll have to go. I'll leave it to you to go investigate that. But when you look at the switches, you'll see, or switches, the parameters, you'll see the the differences between the two. Depends on what you're trying to read in, what you're trying to convert, and what type of format you're going to specify. So the associated input stream converts them to characters using the appropriate encoding that's specified in the stream. No character coding specified means it's going to be assumed to be in the character stream originally. The write's going to do the same, exact opposite. Takes the supplied characters, converts them into the bytes that are using the appropriate encoding, or the default if nothing is specified, and then the associated output stream is created. So closing the conversion streams also closes the associate streams. May not always be desirable. Depends on what you're doing with it. So in terms of working with files, we didn't do any random access in the notepad. Instead, we did a sequential read. So sequential access files is the file I/O stream. So file input stream, file output stream, file reader, and file writer. This is the stuff we've seen in all of the notepad examples, because all of the notepads are reading in a file, and they're putting it into an input stream of some sort, and then they're making an output stream of some sort to save. So the opening and the saving is being created. Constructors always take a string, and they may take a file object, which refers to the file itself as stored on the disk, and then a file descriptor object that describes the type of file that it is, or the name of the file and all the information associated with it. So random is another way of doing it, where we're just going to allow reading and writing at the beginning. Read allows you to read write data beginning at any specified location in the file. You're going to do this if you're keeping, let's say, a file of properties or something. Notepad, we were just reading in everything, reading out everything. We're just going to use a regular or sequential read for it. Randomly, we could look for something. We could put placeholders in the file. Let's say our program was writing preferences or settings or something to a file. We can do that to, say, at index 1, index 10, index 15, index 20, separated out by some sort of logical ordering of 5 or 10 characters or something. And then put different pieces of information there. So we go to a particular spot in the file and we load up the name, and then we load up the color settings, or we load up something else, which is very common, actually. I had to keep track of things, make it persistent between different program usage for different users. Allows you to have a file pointer to use as a guide for a starting point. It's not a subclass of input and output reader or writer, but it supports both the input and the output of the bytes and the characters. So it works with the random access file, actually works with all of the other existing classes, objects. So here's an example. You could cut and paste these examples in this lecture. All of them are executable. They all run fine if you're interested in seeing how this works. And this one is opening up for random access. Very similar to C, we're creating a file pointer, but we don't have pointers. In Java, we have variables. So we're setting this object random access file 1, file 2, creating the object using the object as the pointer. So it's going to be equal to a new, it's going to be equal to a new access file arguments for R, read, write, and read. So we're going to open up both of them. And then throw an exception. This is actually a good example of the exception handling, where we're going to catch a file not found exception. And then in the file not found exception, we're just putting the try in, and we're not actually throwing it here. We're throwing it by default with the catch, because this is going to, there's no way of throwing this. This is going to be thrown automatically. If any of these fail, the exception is going to be thrown, and the exception that's going to be thrown here is file not found. If they're not found, it's not going to throw a corrupted, anything's wrong with the file. The file is found, but you can't open it. It's locked or something. A locked file exception or something is not going to be thrown. Just file not found. And we're going to just basically print out to the screen, hey, file not found. And then we're going to exit, which is actually kind of an interesting thing, because this is going to exit with a code 1000. If we had a method that we called that loaded this object, and the object returned after running, it's going to return 1000. So if you think about concept of method data types, class, running a class, assigning it to, making an instance of the object, running the object. When the object returns back and control comes back to the whatever ran it, it's going to send a code to it, and we can say, hey, we tried to read the file wasn't found. we got this exception. It's a way of sending information back. This is not exception handling. This is method return handling. Because exit's going to return out of system. What is actually exit's going to return completely out. So it's going to basically close down your Java program and take you back to the terminal console. So if you caught it on the terminal console end, then you can say, hey, can't run this program. File's not found or something. So it's yet just another way of, this one here is 200 because this one's throwing a different exception. So it's just a way of catching information to see what happened. This is an I/O error occurred. Probably I couldn't write it or couldn't read it. Couldn't read it, so an I/O error occurred. So this is different types of exceptions that are thrown, I/O exception versus file not found exception. How do you know about all the exceptions? You don't go memorize them. Instead, you go onto the internet or you find a Java book and you go, well, what are all these exceptions I should be catching? What are these things that are going to be thrown? And then you can figure out what's going to happen. And if you go through common examples, you see if they've programmed it properly, they're doing the exception handling. So you can see that, anytime you open and close a file, you're always going to get exception handling. Also, when you go and try to open up a URL, you're going to get exception handling. Try to load a website address, try to upload a file, download a file. Anything that has to do with communication with your program and other programs or other systems is going to throw some sort of an exception. The file class, last but not least on our tour of notepad stuff, we had files. So the class is particularly useful for retrieving information about a directory or file. We're getting it from file chooser, which is a different object. We could get it from file. We can actually create file instances of objects. So the file object automatically represents a path, not necessarily an underlining path, but the path doesn't open files or provide any file processing capabilities. It just gives us the file system path. So we have three constructors here, file with a string name, file with a path and a string name for the name of the file, or a directory, the string name. And we have some main methods that we can do for the file system. So imagine being able to get your file system through file, which represents directories, files, things that are navigational throughout your file manager, file system. Different object than the file chooser object. So it's a little lower level one. In fact, what you can do, and if you go back and look at those notepad examples, you'll see file chooser uses file. There's a file object that represents the file that was selected from the chooser. And then the file that was selected, we're getting from the file object, the name of the file, the path of the file, all the information associated with the file. So if we keep the file object to point to the file that was selected from the chooser, then we can manipulate it through the notepad program and we just write it back out. We know which file was open, we keep the object from the opening. It makes the closing that much easier. We just take the same file and close it, unless we do a save as. And then we change the file information. So the name, the description, all that information about the file we can change and then write that out. So it's very simplified when you can hold it into an object. Adding more efficiency, well then there's this concept of buffered I/O. So what we've looked at so far was the traditional I/O, non-buffered. The same classes we just looked at for characters or bytes can also be buffered. Mostly done with characters actually for buffered I/O. Buffered reader reads text from character input streams, makes it faster because now we're going to use memory to buffer it and hold it. So buffered characters, so it provides an efficient way of reading characters, bytes, and lines. Most of the examples are going to use the buffered. Actually, a couple of them use the input stream, output stream. A couple of them use the formatted streams. We also have a couple of those examples that use the buffered reader. So when you go through the notepad example, especially if you're going to use it as an example for yours, you can use any of the techniques, but they're all represented in those 4 or 5 different notepad versions. Every one of the readers and the file streams and the buffered reader is actually demonstrated as well. So to wrap an input stream reader with a buffered reader, we can go buffered reader in is going to be equal to a new buffered reader, new input stream reader, system in. So we're going to take the information that we're typing in from the system input and add it to a buffered reader. So to wrap it, it's getting kind of loud in the back of that room, this room I should say, thank you. To wrap it, we have the file reader inside of the buffer reader. So it's the same kind of concept, but we're going to take the file from the file name, so file reader. So this is going to be instead of the system in or input reader, so we're going to read the file, so file reader. Can be invoked by an in.readLine as well to read each one of the lines. So just like in other languages, we can read it word by word, byte by byte, character by character, line by line, or just take the whole file. So the file chooser just takes the whole file, actually loads it into a file object, then takes the different parts of the file descriptor and the file contents and uses it. So here's an example. Efficient reader, basically the workable Java code. This is not going to do anything too fancy. It's just going to take and create from a file reader, from an argument to the file you're going to pass it when you run this command. It's going to take in line by line, read it in, and then while it's not the end of the line, keep it, display the lines too, and then close it. So, to close it out to read it. So, supplemental reading, if you're interested in finding out more information, that's basically the nuts and bolts of the file I/O and also the exception handling, which is fairly straightforward. You can't really learn it by listening to me talk about it though. So. It's definitely embedded, both of those two concepts are in every single one of those notepad examples I just showed you. In fact, not a bad idea now to go back and look at it, but I'm not going to do that. So, in essence of keeping this exciting. So, we've looked at notepad enough, in my opinion. So let's take a look here. There was one lecture I wanted to point out. What we just covered was lecture number 7 on the notepad concept. There was one lecture I wanted to talk about, which is number 5, that goes back to Notepad actually and goes back to Swing. This one is for those people who are at this point are overwhelmed, and I've already told a couple people about this as well, and I mentioned it yesterday, but I just want to reiterate the point. If you go into the PowerPoint lecture section, the ones I've been going over are this set here, and I just went over number 7 actually. We've actually gone over number 8 as well. If you go down to the bottom here, into the basic lectures, this is equivalent to an undergraduate course in programming for Java. This, by the way, not to keep reminding you, but this is supposed to be a graduate level course, so this is supposed to be, it is. So it's definitely at a higher level of abstraction. Throughout the breaks, I've had a lot of people come up to me and say, hey, you know what, I don't know anything what you're talking about. I've never had a programming course before. If that's you, you want to be looking down here. And if that's you and you just decided that you better start maybe getting up to speed, number 5 is actually not a bad one for those people who are already up to speed. It goes through in a lot more detail a lot of the different Swing components. So number 5, this is number 5, and these are called review. This is coming, number 5 here is coming out of this set down here under Programming Basics. This is actually about 50 slides, 45 slides, that's going through all of the different components in a lot more detail. In fact, here we have a big picture here that will put some of the pieces together. If you didn't find the Swing stuff that I gave you, if you didn't find it exactly straightforward, and you felt like you wanted a little bit more reading on it in terms of the components, it has this is a very much lower level, although it takes what I did in half hour and does it like in 2 hours, because it's about 50 slides. I'm not going to go through this, by the way. It'll show you though from the JFrame to the JLabels, JText fields. It kind of does a little bit more detail in terms of the windows, labels, text areas, and gives you a lot more examples in terms of, for example, the class JFrame and how to use it. So here's some calls to public JFrame, and then we have JFrame that takes on a string for the title. We used actually both of these two. Well, we also have the set size, a set title. So it's not a bad reference to go through the individual, the set visible. What does the set visible do? Remember I told you, you put a Boolean true or false in there, it makes it so that the window actually, the JFrame actually appears. But you'll see in here, it displays the window in the program, and the value here that can be set, and the default operations for it. We didn't use the add window listener because most of the programs that we did were looking for actions on buttons or actions on typing or menu options, actually, actions on menu options. We didn't do anything related to actions on the window itself, which is where you're going to get the add window listener. So on the window you can tell, well, which component, what did the user do to the window in the JFrame. Different ways of creating the window, different ways of creating the content pane. So the inner areas of the window itself, the container, the get container pane of the class JFrame. So all of the lower methods that I was running and saying, just run this one, just run, add, here we go, add, set layout. If you want this is really good reading actually, if you want the textbook that this comes from, it's Java Programming from Problem Solving to Analysis and Design, 2nd edition. I believe there's a 3rd edition out, but these lectures are from the 2nd edition. But it's not a bad, if you really want to get into this, the book itself, if you don't have any programming experience, is very low level. It's very nice and very user-friendly in terms of the novice or the complete non-programmer. So anyway, everything you wanted to ever know about a J label, J component. So it does a really good job. This particular chapter does a really good job going through it. So I thought I'd point this out as well. So take and use that as you see fit. And then there was more stuff on each one of the concepts. There's about 14 different lectures, all covering the same concepts, but with a lot more detail and a lot slower pace than what I've been covering. So depends on what category you fit into. If you've had a development course before, if you've programmed in any other language, the pace I'm going at is probably too slow for you, but we'll see. Sometimes it's too fast for people, sometimes it's too slow for people. So let's see, I'm going to end this video because we're done with this particular topic.